Okay, let's get started. So I'm going to give a quick overview how you can actually make easy games with Unity. So how you can be a successful game developer for Windows. My name is Kara Kallewart. I'm a product evangelist at Unity Technologies. My job is to go around the world and show how other people can make games. Myself, I used to make games, so I'm very excited to be here. And the benefit of today, of watching here my 20-25 minute presentation, is that you will see how easy it actually is to make games with Unity. So what I have here, I have a little tiny game where I have my character. I can walk around and I shoot my other characters. Okay, and whoops, we fall to the floor here. Okay, and what we see is here the environment. Okay, and we see a character coming, and we see our character with the animations. We're going to quickly recreate a part of the game and explain how it all works. And then later on, Corey Johnson will show how we actually take this game and export it. So what we're going to create a new scene. Okay. Totally empty scene, and we're going to start to create a similar experience. So let me create here a plane. So you can use simple objects in Unity. I have here a plane. Okay. And Unity comes with a lot of prefabs to make it easy for you to make a game. So some of the prefabs can be found here. Import a package. And one of those packages is a character controller. When I import that, it's a setup for a first person and a third person game. So I can here go, I imported that already, and my character controller, I have a first person and a third person. And I put the first person here in my scene. Okay. And then right away here, press play. I can actually preview the game in the game viewport. This viewport is my editor, so I create everything. The hierarchy lists all the objects that are in my scene. I have a first person, I have a plane, and I have a camera. I don't need that camera anymore. And the project here, I list all the objects that I imported. I list also my scenes, my scripts. Okay. I want to make this a little bit nicer, so I'm going to add here texture to it. So I imported some textures. Okay. And we have also a functionality to find easily objects here. Okay. So how do you import textures? Okay. I can go here to my desktop and I'm going to select the texture here. And I have here like a sand texture, a PSD file. In native, we can drag and drop the PSD, the Photoshop file, directly into Unity. And we drag it here on the platform. And let's add a light in my scene, like a directional light. And press play. And now I can already walk around in my scene. Okay. I'm going to add some of the 3D objects that we saw before in our game. So we're going to go here to my objects. Look for it. So I have here the platform. I imported the same way. This is an FBX, so you drag and drop the FBX file format in there. And we're going to drag and drop the FBX file in there. It's a bit small, and we can easily scale it. Or we can scale it directly here in the model, the scale factors, so that you can control the scale factors coming from different software packages. Okay. I'm going to place this up. Take my first person, place it up here. And what we're going to do, we're going to add a collider to that object so we don't fall through it. Add a physics, a box collider. Press play. And now we can walk on our platform already here. Okay. Scale this a bit more here, the ground. Okay. I'm going to add some walls to it. So I imported here 3D walls in my scene. I have a piece of a wall. Drag and drop that in my scene here. And we can duplicate it. We're going to move it. Or snap it. So that's how we start to create the level that you saw before. Okay. What I've done, I went ahead and I created more walls. So we're going to remove this here. Okay. And I have here my level So I just game level, and I have duplicated here more walls. Okay. Oh, that's why. I'm gonna go to my platform here. Put it back to the original scale. Okay. And I'm going to scale here my ground. And my first person, I'm going to place it nicely on top of one of the platforms. Place it here. And bring it up. So right now we have already our level built here, and I can walk around. Okay. Let's create some interactivity. Let's add a weapon to there and start to shoot with it. Okay. So I have here somewhere a bazooka in my scene. That object comes from Maya 3ds Max, and I added some animations to it. So here my animation tab, we can see we have an idle animation and a shoot animation. It was one animation, and then here in Unity you can nicely split it in two different animations. So I have an idle animation, and I have here the shoot animation from frame 60 to frame 75. My idle animation, I put it here to loop. So when I trigger the idle animation, it will automatically loop the animation. So I'm going to take the bazooka, go to my first person, and attach it to my camera. Bring it down. Okay, I'm going to bring it a little bit to the right here. And we're going to bring it a little bit more forward. There we have it. Okay. And now when I press play and I look around, my bazooka will follow my camera because it's attached to it. Okay. Let's add a little bullet for it. So we're going to create here like a sphere. Okay, and we'll move it forward. Scale it. Okay. And we can create a material for it. Okay, we can change the color also, more to yellow. And we drag and drop that material on our sphere. Okay. We're going to add some gravity to it, so when I shoot it, it falls down. So simply select the object, and then you can add physics to it, a rigid body. So when I press play here now, the sphere falls on the floor. Okay. So we're going to add a little script that when we it automatically destroys the sphere. So if you shoot a lot of spheres, you want to take it out of in the environment. So we're going to create here a script. Okay, you can create a script here, but I have it pre-made here. And okay, so a really simple script. We're going to destroy the game object, the object that's in my scene, after 5 seconds. Okay, take it and I drag it on my sphere. When I press play, after 5 seconds, it will remove the sphere fully out of my game. So, and it's gone. Now, from an artist viewpoint, I really want that I easily can work together with my programmer. Because right now, if I want to change the settings, I really have to contact the program and ask, hey, can you change that? Well, the cool thing is in Unity, you can actually expose and you can create sliders. So we're going to open that script here. And we're going to create a slider for the value of the time. So the number 5 here, I'm going to say the bullet lifetime, a nice BLT. Okay. And the variable BLT is actually a float. Then it's equal to 5 seconds at the moment. Okay. And what we have here now, when I select my sphere here, okay. What's that? Okay. Oh, it has to be outside the function, of course. Okay. And your BLT is a float that's equal to 5 seconds at the moment. I save this. And now we're going to have here the slider. So the artist can easily fine-tune and tune the game here now without disturbing the programmer. Okay. The next step is that we want to, thanks to those exposed parameters, of course, we can reuse scripts from other projects in the scene. And what we're going to do, we're going to create here a placeholder where we're going to click and we're going to duplicate and instantiate that sphere to here by script and shoot it forward. So we're going to select here my bazooka. I'm going to add an empty object. I'm going to place it in front of my bazooka. Okay. And I'm going to make it a child of my bazooka, so when I look around, it follows my bazooka. And we're going to make it more visible by adding a button here to it. Click. So then we easily can, if we don't have selected, I can easily find it in my scene. I'm going to add here a script. We're going to shoot the bullet. So I have here somewhere a shoot script. Shoot script, okay. What we're going to shoot, we're going to use that bullet, that sphere. Okay. And what is a bazooka? This is the object that contains the animation. So press play. And now I'm already shooting the bullet here. Okay. What we want to do is we want to add some flames and particles to that object. How can we do that? We can easily create a particle system here in Unity. Okay, and then we can start to change those particles, and we can make them a bit the size. We can change of the particles here. Okay, and we can make them a bit bigger. We can make them live shorter, so they don't live so long, the particles. Okay, and then we can easily change the colors over lifetime. Okay, so that the particles, at the moment they here white particles. So click, I can say in the beginning, my particles should be more red. Okay, then over time they become yellow. Okay, you can move that to here. And then over time they become actually dark particles. Okay. And okay. And then they fade out my particles, so we can change the alpha channel of my particles. Okay. And that's how we start. Hey, if I continue this and I work here a bit more on, I'm going to add here more emission. Okay. And we actually can start to create flames in our game. Okay. But the cool thing is that we also have a store actually. And that store is created by our community. Every community member can submit Archon scripts, editor extensions to our store. And it's like a 70-30 model. You get 70 and we take 30. And here in that store, I actually can look for particles. And I can download those particles directly in my game here. So you see the store is coming up here. And if I type in here shuriken, that's the name of our particle system, I'm going to see like all examples. Okay, and I could download this one. I bought it already. Okay, and it's already imported in our scene, in our project here. So the cool thing is I have here one of those particle system is a fire base here, so I can show you that. Okay. And we have here a particle system of nice fire that I got from our store. Okay. And I'm going to use that on my sphere. So I have here my sphere. Okay, I'm going to take that particle system, drag it on there, and I'm going to place it nicely at the same position. Okay. When I press play, and we have the fire coming out of the sphere already. Okay. So when I press play now, we will be nicely shooting fireballs in our game. Okay. And there's a lot you can do. We can add here nicely a skybox also. So in the render settings, and we're going to add a skybox. So we see out the materials here. I can make it nicely in text. And then scroll down. And we take a nice sunny sky here. And it's already applied to it. Okay. Okay. So what we want to do is also we want to make it right away friendly for mobile, so that we have our touch inputs. Okay. You don't need to actually do any programming almost for that. We have a package for you ready, a mobile package. Okay, I imported this here already. And that mobile package comes with example scenes, but also with prefabs, pre-made like for if you want to set up first person or third person or a top-down game. So what we're going to do, we're going to take here the prefab or first person, and I drag this in my scene. Okay. And I'm going to call this one my first person for mobile. Because you see already the touch inputs on the screen. Okay. Take it out and rename this as my joysticks here. Those are my joysticks. Okay. So my first person for mobile, I'm going to place the same position where my first person is for mouse and keyboard. Okay. And we're going to bring it down so it's exact same position. What we can do is we can take the weapon of our first person for mouse and keyboard. We're going to duplicate that and give it to the first person of our mobile camera. Okay, and there we have it. So I can deactivate now my first person for mouse and keyboard, and I have my mobile version already ready. Okay. A few things that we can do for to optimize our game so that we don't have too many draw calls. And what we can do for that, I'm going to deactivate here my mobile now so we can continue on the computer here. One of those tools is that we have occlusion culling. So when I look here at my stats and I press play, okay, I have about 150 draw calls here. So what I want to do, I want to reduce them. And we're going to go here to Windows, occlusion culling. Okay. Occlusion culling will make sure that we only calculate what we actually visually see. By default, Unity is using frustum culling, so it will calculate what's in the camera, but also when things are obstructed, like it's an object behind it, then you will calculate that, but you don't actually see it. Yeah. And with occlusion culling, I'm going to put the cell size here a bit bigger so you see, it will place the camera in every cell, okay, and calculate what I actually can see and not see, and use that information at runtime. So we're going to bake here our scene for that. Okay, and then press play here. We see our draw call now dropped to like between up to 70, 80 draw calls. Stop that now. Another thing that we can do, we can overlight. We can go here and we can activate shadows if we want on it. And then we can bake that all information too. So there's a lot of tools built in Unity for optimization. Another tool that's very handy is our profiler. Okay. When you press play here, we're gonna have we do profiling on the CPU, the GPU, the rendering, the memory, the audio, and the physics. Okay, and then you can stop it and scroll down, scroll in it, and then find your bottlenecks. And here for the memory, we have a new feature in 4.1. You can get a detailed information about the memory. So you can select here like your textures, select the texture, see how it takes it in the memory, and also you see it where it's located in your project directly. Okay, so I'm going to open here the final project here. Okay, that we created, the scene here, and speed up the process by explaining it from there. Okay, so this main character is again also a character, a 3D object that we imported from Maya. And what we did with that character, here the character, in our settings in the rig we say it's humanoid. What it does in the background, it figures out what is the head, what's the leg, what's the hands. So it can apply animations from other characters directly on this character. And when we configure this, I'll show you in the background. Let's go in the back. Okay. Well, we can select here the character and it automatically makes it an avatar out of it. And what we did, we wanted to have animations on it. So we took the animations from a different character here. And I have here like a run animations. If I select here an idle animation, okay, I have here an idle animation. And we see this on this character here, but I want to actually see it on my character. I just drag and drop my character in there, and I see an idle animation here on it. Okay. The same as with the run animation. Okay, I have actually 4 run animations on it. Okay, so we have running forward, left, right, back, and left. Okay, what we see is here is viewed nicely. We can go from idle to run just by creating a transition, and it takes care of the foot siding for you. And the same is with run to back, and then from run to dive, where we can easily have all the different animations blending between each other. And I can actually show you nicely the sliders here we created. Okay, the menu is a bit small here. Press play. Okay, we can actually use those sliders here. Now, see, that's the input of left and right, up and down on my keyboard or on my joystick, and left and right on my character. And we see nicely the updates on my character here. Okay, like when I run forward, left, right, forward, and back, and then nicely we can blend in between those animations thanks to this blend tree here. Okay. So in that way, because we can nicely bend our animations and go from another state to another state, when I press play here, okay, I have my joysticks here too. Okay. We can also use our keyboards where my character can run forward, and then we can shoot our fireballs. And we use exactly the same script that we used on our character, our first-person character. Okay. We have this character here trying to attack us, and we use particles like we created before. With this character here, okay, we have this other character here, this robot. Okay, we want him to attack our robot here. No, we did that for what we used for that was our navigation mesh, and have it activated here. So you select the objects that you don't want to use, where the character can run over it, and you put them to static. Okay, I selected all the bridges and all the platforms. Went to navigation. Bake, and click the bake button, and that creates me that blue mesh, and that's where our character can run around. Then this robot itself, I set a component, navigation, and I added a nav mesh agent. So this character belongs to that nav mesh now. Okay, and we added some scripts to it that uses some of our strong APIs for navigation. Edit script here. Okay. So one of the scripts says it looks really. It looks at the target and it looks at the remaining distance. If the remaining distance is more than a certain distance, then set the speed of my character and my animations to 1. So basically, I'm gonna walk. And if it's closer, I put the speed to 0 and stand still. Okay, and that's how we get our navigation mesh of our character attacking our robot. He's trying to attack our robot here. So he's coming to me here. Okay, and I start to shoot him. So he is done. So that was a quick overview on actually how to create games with Unity, and where you can see how easy it is to create your environment, create interactivity. And then the next step is how you actually build this for the different platforms. And Corey Johnson will take it over from here.
Oh, thanks, Carl. Am I on? Hey, come on. Oh, that's fine.
Thank you, everybody.
So I was originally supposed to go first, and then Carl's so much faster at me, and we had a condensed time to build a game, so that was really blazing fast. I just want to remind everybody that we are on TV, hi Channel 9 at home. If you want to interact with us, make sure you use the CH9 Live tag, and then our moderators will pick it up. And then if you want to talk to the greater Unity community, hashtag Unity3D is always a good one. So my name is Corey Johnson. I'm a field engineer for Unity. Carl is one of our evangelists. He just took you through what I call the beginning to the end. So, and that was really blazing fast. As some of you saw it like last night, but I just wanted to see if there's any questions about how things worked or anything at all. We can address them now about like how building games in Unity or anything like that. Nope. All right. So now I'm going to get to the end of the end. So we've built a game in Unity. You may have deployed it to other platforms or not, but I'm going to talk about, okay, so I have this game, I can hit play, I'm happy with it, and now I want to build it for Windows Store. So I'm going to go through the Unity side, which is our build menu, player settings, talk about those settings, and then I'm going to take you into the Visual Studio side and talk about that. And let's get to it. So opening up Unity, we have our game here that he just built. So what I'm going to do is I'm going to go to File, Build Settings. And here you see all of our different platforms. One of the strengths of Unity is our cross-platform ability. We are already on Windows Store apps. So if we were on something else like PC, Mac standalone, we would just hit the switch platform button and it would transfer and do any kind of changes to any assets that it needed to switch over to that platform. Down here is our player settings button, and with the inspector selected over on the right, that's actually pretty good to see. We have what we call our player settings. So our player is what we call what you're going to deploy. When you hear Unity folks talk about a player, that's what actually gets deployed with your app into it. So a Unity app is always a player for the particular platform. It's always written in native. So it's very performant. It's not like we're running scripts. All your scripts are then compiled into native code and built into an assembly with your game scripts. And then we have all the art assets and resources that you have built into a package as well. So those three things get built in for whatever platform we're deploying to and pushed out. So here you can do stuff like Carl named this product Ice Cream. We can change our different icons and whatnot. Pretty standard stuff that you would build, and these are cross-platform. Down below here we have per platform settings. For Windows Store right now, the resolution, icon are all shared across all of the platforms, so you don't really need to worry about those. We have other settings here that if you're optimizing, you can turn on and off static and dynamic batching. You can change the accelerometer frequency, how fast, how much we pull it. You can define specific scripting defines for this platform. So if you have your own features or things like that that you want to turn on per platform, you can do it in code by pound ifdef, and then you can define those symbols here. And here under publishing settings, it's actually kind of big, so I'm going to zoom back out. Here, and I'll show you where this kind of gets mapped to in the Visual Studio side. But here you can name all your things. Again, we call the package Ice Cream, so the actual the AppX is going to be called Ice Cream. You can change a version number if you want and set it to default. You can overload, and by default we use the Windows logo, but you can select your own logos and things like that for the installer, the app executable icon. You can override a couple like background color, clear color, things like that, and you can turn on and off a bunch of capabilities for Windows Store. So once that all set up, I just need to hit Build, and I already have a folder called Store Build, and I'm gonna select that folder, And what we're doing right now, like I said, we are compiling all your scripts, taking all your assets, and taking an already pre-built player for Windows Store, copying them over, and building out a Visual Studio project for you. And we'll take a second. Questions so far on the Unity side of things? I know a lot. I know pretty much everyone here is already Unity developer. Is that true? So you're like, yeah, okay, got it. Online's good. So once we build that, we get presented with the parent folder for wherever we created that folder. So I'm just gonna click into store build, and I have in here a solution file. It's a visual, so we do require currently, Windows 8 and Visual Studio 2012. So now I have a solution, and I'm just going to kind of walk you through it. I mean, are most people here Windows developers, Visual Studio people? So I'm just kind of give you the overall layout. You'll see that. I mean, it's all pretty, so we have what we call a template that we have that gets deployed with the editor, and that's where we copy things from to create this. And so you'll see assembly title, template. Those are just things, that's just copied directly from our template solution file that we use to create this. You can come in here and hand edit these after the fact. So almost everything in here is going to be not overridden on the second time. So for instance, here, if I open up my Apex manifest and look at our capabilities, here's where all those map up from Unity. All those checkboxes would be checked right here if I checked any on. Here's where all the display names and what supported rotations and things that we did, where the color override went. Here's our default logo. So the Apex manifests, any XAML files, any of the source from the template are not going to be overwritten every time you build from Unity. So what's going to be rebuilt is, new assets are going to be either updated or added to your resources and your assets. Your scripts are obviously going to be recompiled and brought over. And what that means is you can come into here and go ahead, and if you want to come into the XAML here and add customizations and support things like tiles and things like that, you can do that and not have to worry about accidentally overwriting them. Because what you need to do to get them to be regenerated is just delete any one of these, build it from Unity, and then those files will be regenerated using your values, the defaults from the template applied with your values from the player setting. Again, here's your data. Here's your resources folder where any resources that you would have. Your main data, common. Here. So what I'm going to do is now I'm going to deploy it to, I have a Surface RT device down here. And I'm just going to deploy it. So the first thing will happen is that you'll have it default on a local machine. Now, if I came into my configuration manager and switched this to x86 or x64 and built on my local machine, I'd basically be building a desktop app, and it would just work on my local machine, no problems. But we're talking about, I'm specifically showing ARM, so I'm going to switch this back to ARM. And I want to do it on a remote machine. Now, to do remote machine debugging, you will need to download the remote debugger, Visual Studio 2012 remote debugging extensions on your Surface. It's very fast. It's, I forget how many megs, but you just download it directly onto your RT device and run it. And I actually don't have view on this, so sorry about this, but I have it installed, I hit it, and it's just going to, maybe. Remove debugger, do it. So it's going to switch me over to desktop mode, pop open a a little terminal. On here, actually, on here we just, one of the things to make it easier under the Tools menu, Options, I'm just switching it to no authentication and allow anybody to debug. So by default, you can, let's say you need Windows authentication, so you need to have the same user on both devices, so that way you can debug across. There's a setting under Tools Options, just say no authentication and allow, so that way it won't authenticate, but it'll still check the user, but then you just check allow any user to debug, and then it's wide open, so if one of you guys was out there and could find my IP address, you could just deploy to my Surface and totally mess up my presentation. Don't do it. Like unfortunately, I don't have screen sharing on my RT device. So the remote machine, if I come into Projects, Properties, and the first time you do it, it will pop open a wizard and ask you what you do, and it looks like this. And here it automatically found the name of my device is AppLab3, so I can just select it. It tells me authentication is not enabled. You know, bad things can happen. Don't worry about it. You know. You can also use IP address if you need to. If you can't find on this, if you're not on the same subnet and it's hard to find, you can just get your IP address and type it in and be fine. So now once I've done that, I'm going to hit deploy on my machine, and it's copying files over, and boom, little loading screen, powering up. And now, even in release, we do deploy all the PDBs, so you can get good, if your game does crash. I don't think we have mobile, so we have, I can't see, so I'm going to run off the stage, but you get the drift. This is debug, so it's a little hitchy, but on release it looks really good. So I'm going to go ahead and stop that. Now, Carl likes to use JavaScript for a lot of his scripting. And we don't currently support debugging user scripts on anything other than C#. So what I'm going to do is I'm going to show you kind of another quick end-to-end. I'm just going to create a quick new project, new Unity project 2. Don't save because I don't know what he did. I'm super lazy and I get nervous typing in front of people, so I'm just going to do this. I'm going to switch out everything to C#. And come back. So I'm just going to create a cube, zoom in on it. I'm going to align my camera to it. Oop, that's not what I wanted. I'm going to align view to selected. I'm going to create a quick little C# script. I'm going to call it spin. Double click on it to open it up. Paste in my C# script. So all we do here is on update. I'm just going to spin. Save. Make sure I'm going to quick add a light. Oh, that is not the right spin script. There we go. This one's muy bueno. So I'm just renaming it because our class has to be the same name as the file. And just gonna assign my camera here. Somewhere in the middle is good enough. And I'm doing all that in play mode, of course. Hit play, and I am slowly rotating. So I'll just come up here and say float. Speed equals 10 times speed times speed, save, and you are correct. That's what happens when I watch Carl too long. So just so you know, JavaScript, the file is inherently built into a class, and C#. Have to. All right, so now when I select my cube, and I have, where's my script? I didn't apply it yet, which is why I wasn't moving. So now I have a little script. I can hit play. My cube is going to spin at some rate. It's noticeable. So now I'm going to build this. So here, it's a new project, so I need to switch platform. And real quick, I want to talk about I just learned this keyboard shortcut. Super mega awesome. So we have 4 different types of solutions that we can generate for you. We have D3D11 and XAML projects. The difference there is D3D11 are just a single window with D3D loaded. There's no XAML on top of it. It's slightly more performant because it doesn't have to handle the XAML stuff. So if you're doing something that you don't need any kind of XAML overlays for and you're just purely worried about performance, the D3Ds are better performant. We have a C# solution, which allows you to manage assemblies. And then C++ if you want to statically link some libs. I'm going to choose XAML C# and hit build. And I'm going to create a new folder called build. Select it. One of the nice things about Windows 8 is deploying for Windows 8 is that you get this Visual Studio, so you can use Visual Studio end to end. And real quick, I'll just kind of show you file, edit preferences, external tools. You can browse for another script editor if you want to use Visual Studio by default to open it up your scripts and do your editing there. You'll lose some of the autocomplete that we have built into our mono that we ship with it, but there's an excellent plugin called Unity VS which adds that back in. And there's other ways you can get the definition and stuff like that. So now I have built. I am going to open my build folder, open my new Unity project. Remote machine, here you can see that it's searching. This is the first time I've used it, so I can put the address in here, but I can see applad 3. Do I still? I still have it running, the remote debugger running from last time, so I'm going to select this. I'm building in debug. I want to double check. By default, I'm building for ARM. And I'm going to hit deploy. Just takes a minute. I'm on a wired connection. So you can use a wired connection. You can use the Wi-Fi, which is super nice, especially if you're on the same subnet. It just finds it. You're good to go. You can also copy the files over via USB, however you want, depending on some people have really complex network structures, so it's hard. Like last night, we were trying to figure out which magic port got us on the same subnet to make this seamless. All those options are available to you. And I am now running a spinning cube on my surface, which is awesome. So now what I can do is, show the right one. I'm going to open a file. I'm going to find where my project is, which is assets. I'm going to open my spin and see if I can't drop a breakpoint. Why isn't that working? Oh no, where's my window go? Yes. One thing you can do is you can come in and add an existing project. It's going to take me automatically to my default folder. And inside, not inside the build folder, but inside the assembly or inside the project folder, we have the C#. We have the solution files for your C#. You can open those up. So now I have this assembly C# VS. So I have my spin file right here. It's available for me. And again, once you add that the first time, we don't blow away the Visual Studio. We don't blow away the Visual Studio solution file, so it's automatically going to be added and updated for you. So, let's see here. I changed it, so I need to re-add this guy. Uh-oh. Oops, so it debug. I'm not hitting it. Totally blanking. So I need to switch over to mixed mode so I can debug native and managed apps, and this will work. Vlad, you know where? What's that? There we go. Properties, configuration. Where is it? There we go. Mixed. Let's make sure that gets saved. All right, so I'm mixed. Try that one more time. Oh no. Uh-oh. Try to manage only. All right, so it looks like we're having a little bit issue. Normally, and we can show it later on phone, you can debug user scripts and all your XAML stuff all in one solution. You can set breakpoints in it. You get watch window, locals, all the good stuff. I'm having a little bit of presentation luck here. So let me switch back to my PowerPoint, make sure I didn't forget anything. All right. That is a quick overview of kind of like how to deploy it. You guys are all Unity developers, so it's really fast and easy. Like the Unity side, you know exactly what it is. We looked at the solution file that gets generated a little bit, so you kind of know what you're looking at. It's no different than other platforms where you get solution files generated for you. We don't override a lot of the settings and files that you'll need to work with to add in some of the features that we're going to show later today in the advanced sections. So you don't need to worry about like, oh, I did some work to add tiles and things like that. So what happens if you were checking your email the whole time today? Don't worry about it. I was actually mostly reading the, oops. Go away. I was mostly reading the documentation to you under help. When you install the Windows Store app add-on, just like all of our other platforms, you're going to get a Unity manual for this particular platform. And I can just do a find Metro. And you can find a getting started guide. And you can find all sorts of things, information about plugins, project types. We're going to go over a lot of this information in detail right after this with Randy. You can find some examples, which we're going to talk about probably later, and talk about how you do things like pass messaging back and forth between Windows Store platform and Unity. And the beauty of having short slides is you don't have to worry about starting over from the beginning. Any questions? And a little caveat is please remind me to repeat the questions for online because I always forget. What's coming up right after me is Randy with a deep dive talking about like things that we had to do and optimizations and things like that for it. Later on, we're going to have people that have shipped games here, and they're going to tell you tips and tricks and like how to interact with the tiles and contracts and things like that. But when in doubt, yell it out. So if you're not sure if it's going to get answered later, go ahead, feel free to ask me. I do have a question from Daniel P. online. Hello, I want to make a game in 2D. Can I do that with Unity? The question is yes, we are a 3D engine, but we have many successful apps in 2D. The way to do that is we have third-party packages out there that help, and I believe they're going to be talking about later how to do sprite animations and things like that. You basically just put those on billboards and then put it into orthographic view, and or not, depending if you want some parallax built in for free. And you basically just ignore one of the axes, and it's not that difficult, especially if you use some of our third-party apps that, or third-party packages on our asset store that make it super easy for you. Questions from the live studio audience?
How much will we need to understand about XML to understand this stuff? I know nothing.
It's okay. I didn't understand a lot of it until a few days ago. It's not super hard. It's all very well documented on MSDN and on the Windows developer site. If you just want to make a game that runs in the store or is on Windows 8 desktop, you don't need to know any of it. You can just build an x86, deploy it out there. If you want to build into ARM, then by default, we take care of the bare minimum for you. If you want to interact with, if you have a game that, say, is you sell packets of cards and you want them to search your app for cards and stuff, you would need to know some. But to get your pure gameplay, like you saw us, like we're by far not the experts in it, so we stay away from it, especially for presentation purposes. But like, we built that game, we got it deployed, we got it running without any XAML.
But it's what you would use if you wanted live files and stuff.
Yeah, exactly. It's the same stuff that you do as if you were not using Unity to do it.
If my scripts are just JavaScript, you said I can't debug, but what if I have no errors or problems? Can I publish this JavaScript code?
Yes.
Okay, repeat question.
Oh. So his question was that he already has a Unity project. He uses JavaScript in his case, or Boo. Any Boo users out there? No?
Or you can't deploy today.
What's that?
We can't do it today.
Oh, okay. So we can't deploy today. We plan on supporting it in the future. We can talk offline about when that future will become an actuality.
So I can't upload today. I have to wait for an update for publish the JavaScript version.
Yes, currently.
And on where's the problem with that? Is that the WACK doesn't run, or will Microsoft just not accept it?
The WAC won't pass, and Microsoft won't accept it for that.
Okay.
So, first one, then the other. Another online question: can we use Unity Project across both Windows 8 and Windows Phone beta plugins? Also, should we switch to Windows Store beta from the Metro Alpha builds? Can we use Unity Project across both? At Unity, we always say back up your project folder. So always back up your project folder. We plan on having one Windows 8 build in the future, so it'll all be in, just like all the other, most of the other platforms, where we'll have one add-on for all of the Windows 8 family. So you will be able to use one project folder in the future. We're in beta. We're working towards that now. We're getting pretty close. Also, should we switch to Windows Store beta from the Metro Alpha builds? Yes. The beta is where the future of development for Windows Store is happening before release. So if you're in our beta and alpha programs, you should follow along and update with each release. Other questions? Oh, one more.
Are there other potential restrictions other than JavaScript of classes you can't use, namespaces you can't use?
Yes, and that is covered by my illustrious companion Randy in mere moments as soon as we get me off the stage. Maybe a couple extra moments. I got to hobble. All right, cool. Thanks, guys.